It is time for Astronomy Daily Live. It's 2 hours UTC on the 28th of March, 2018. Hey, everybody. Glad you could stop in for another hour-ish long live stream where we gather a circle of friends together and talk astronomy for an hour. We, turn off the TV, forget the news. Let's think about galaxies and binary stars and planets and nebulae and supernovae and whatever else uh, trips are fancy. Yeah, let's talk about telescopes and eyepieces and CCD cameras and doing photometry. Ah, it's been a maddening day, and it's not. I'm not any closer to working this out than what I was several days ago. This trying to measure the magnitudes of astronomical objects, the brightnesses of astronomical objects, is maddening. It's absolutely maddening. Let me reload this. It looks like I should be live. Yeah, it's absolutely maddening. Okay, what I've got, right? I've got this telescope right back here, right? It's a Celestron Nexstar 8SE. It's an 8-inch. It's a 0.2 meter telescope. 0.2 meters makes it sound, you know, big. It's an 8-inch scope, right? It's an 8-inch. I have a S-Big ST7ME CCD camera, 16-bit. I'm still saying it's a pretty darn good camera. Still thinking that. I'm thinking it, at least. Um, and so what I've been doing is trying to evaluate how good of a system this is in terms of doing two things. Um, Doing astrometry, which is the measurement of the positions of targets, and doing photometry, which is the measurement of the brightnesses of targets. And the astrometry, so what I can do, right, is I can um, image sort of a rich field of stars, say. So I've been pointing it at um, at a couple of different clusters. M41, which is a very awesome, beautiful um, open cluster over in Canis Major, just south of Sirius, maybe 3 or 4 degrees south of Sirius. And in fact, over on cloudynights.com, somebody just posted an awesome color picture of M41. So go over to cloudynights.com, take a look at that. Put this down a little bit more. There we go. Take a look at that. Uh, so you sort of see what I'm dealing with. Now, my field of view is 12 arc minutes wide and 8 high. So I'm just getting a section of that cluster, right? I've also been looking at M46, which is just to the east of Sirius. So M41 is a pretty good binocular object. If you're in a dark sky, you can definitely tell that there's like a fuzzy patch below Sirius. There, I'm playing with my focus now. Okay, I'll point that down a little bit more. No rotation, no anything else. Okay, and so I've been using those two clusters as sort of my, you know, nice, rich field of stars, good representation of different magnitudes, brightnesses, all of that. It still isn't quite straight. I want this to be parallel with the edge of my frame. So yeah, all right. So a nice representation of stars, right? And so then what I can do is I can go to a catalog of stars, and I've chosen Gaia. The Gaia catalog goes down to, I don't know, 18th or 19th magnitude. There's just millions and millions and millions of stars, much fainter than what I'm going to be able to see with this scope. So that everything that I see with this system uh, should show up on the Gaia catalog, right? So when I go to measure the positions of all the stars in my field of view, and I compare those positions to the positions that Gaia says they are, I'm getting an accuracy of about a third of an arc second, and on my pixel scale, which is about almost one um, um, arc second per pixel, I'm getting about a third of a pixel, right? And a precision of about the same or so. So that's very, very good, right? Anything less than a pixel accuracy and precision is great, is really, really great. I'm gonna pop open my chat here so I can follow that as well. Hey there, Tom. Hope you're doing well tonight. I'm going insane. I'm just going absolutely insane. The Astrometry is beautiful, right? It's the photometry that is just driving me bonkers. Okay, because so I can do exactly the same thing for photometry, right? I can measure the brightnesses of all of these stars, and I do that by um, uh, drawing a little circle around each of the stars and adding up the brightness of the pixel, the value of the pixel at that point, dividing it by the area, and then so that's going to be a count or a flux per unit area, right? And then I do exactly the same thing. I I take a little ring around that star. It doesn't include the star or any nearby stars to measure the sky. So I've still got the sky brightness to deal with. Now these images are all calibrated in that they are dark subtracted and flat fielded. So I've taken into account all the electronics, uh, all the slight differences in gain pixel to pixel. I think that's probably okay. Looks okay. you know, nothing surprising there at all. Okay, now I can't measure the actual magnitudes of these stars, but what I can do is I can measure the differences in magnitudes between um, stars. So I can take a reference star, and it doesn't matter which one I use. Um, so I can just sort of arbitrarily choose one of the stars in the field of view, and I can say, okay, you know, this has a certain flux, right? And I use that as a reference, okay? And then I can measure the fluxes of all the other stars in that field of view, and I can compute a magnitude difference. It's a very, very simple equation. It's just a logarithmic thing. Simple, 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 right? And so I I can measure the brightness differences between, say, two stars, right? Now I can go to the Gaia catalog. Oh, and here's just another piece of information. Um, I'm I I made these images with absolutely no filters at all. It was just completely wide open, right? No filter whatsoever. It's just whatever the the sensitivity of the CCD chip is in terms of um, wavelength. So it's very, very, very broadband. I mean, um, it basically covers, you know, the entire visible spectrum, right? So I can go now to Gaia, to the Gaia um, star catalog, and they have also measured the actual magnitudes of these stars, you know, the visual magnitudes of these stars, which they're calling G magnitudes. And I looked it up. They're also very, very broadband. So, you know, it's probably not exactly, but it's it. You know, it, if there's any kind of differences, you know, between those two, it should at least be consistent, right? So then, so I can also calculate the difference between the magnitudes of those stars, and that's just a simple subtraction, right? You know, star A is a magnitude 7, and star B is a magnitude 8. The difference is 1 magnitude, right? And so I can measure and calculate the magnitude differences that I'm getting, and I can compare those differences to the star catalog differences. And what I would like to see, right, is that my differences very, very closely match the differences in the catalog, and that that matching, you know, whatever it is consistent. And what I'm seeing, and this is the thing that is just driving me insane, is that um, you know, sometimes it's a very good match between the differences, you know, between brightnesses of stars. Sometimes it's a very good match. Sometimes it's the opposite of a good match. It's really, really terrible, really terrible. So I'm I'm what's driving me absolutely insane is that I'm not seeing a consistent um, accuracy. Even if the accuracy was poor, say I was off, by half a magnitude. Well, if I was consistently off by half a magnitude, I would say I would say this system just isn't good enough, right? It's not good enough, to do the thing that I want to be able to do. But what instead I'm seeing is that sometimes it's really good, like, millimagnitudes. And sometimes it's 2 magnitudes. It's all over the place. And I cannot for the life of me account for this. It's absolutely maddening. And, I've spent yet another full day working on this, trying to understand why, you know, as I said, if this system can't, perform as well as I would like, I can accept that. I mean, that would be a real bummer, right? But I could accept that. I could say, okay, this this system, is only good to a third of a magnitude, or like half a magnitude, whatever, right? But no, okay. Sometimes it depends, and I haven't. There doesn't seem to be any kind of dependency there at all yet. So I'm still looking. It's sort of looking like maybe I'm not matching up um, exactly the right stars, depending. Well, so yeah, there's a few things that I still need to look at to make absolute sure that that star that I'm measuring data is actually that star in the catalog. But it's you know for the most part that I mean, I've confirmed that. There might be a couple that I'm not matching up well, but it's absolutely maddening that it's not being consistent. And as I said, I mean, uh, if I'm not able to get less than like a tenth of a magnitude accuracy, and a tenth of a magnitude precision, then this thing just isn't all that great. But sometimes I'm getting, as I said, millimagnitude, less less than a tenth of a magnitude um, accuracy, but the precision is absolutely huge. And so that means that I'm not being consistent, and it's maddening. Now I have noticed that my focus isn't all that great, and you know that that isn't really a problem, because when I'm doing, differential photometry, which is um, what this is, then a lot of things don't matter. Things like the atmospheric extinction doesn't matter. Um, they could be donuts. I mean, they could be so completely out of focus, as long as I am able to add up all that flux and divide by the area, to get a um, unit um, area flux. It doesn't even matter if they're out of focus. Doesn't really matter. Um, Now, So yeah, I'm not I'm not not too sure. The measurement of the sky, the background sky, is pretty consistent. It's pretty consistent. I don't have a number to put on that, but it's you know pretty consistent. Um, so yeah, for some reason the brightnesses of these stars um, are just yeah I don't know. I don't know yet. And as I said, I when I started this, that I wanted to, take you all on this journey with me, so you can sort of see what astronomers, have to deal with in terms of data, because you know uh, now the other problems that I had in terms of tracking and field rotation, those those problems have been solved. In fact, my I've got a set of 20 images, 20 two-second exposures that I've stacked of M46, and I'm seeing the little planetary nebula that's excuse me, it's actually behind that cluster. So, it's making a pretty picture, but it's crap because as far as I can tell, the photometry is absolutely is terrible. Is absolutely terrible. So to me, I don't care what it looks like. If the numbers aren't right, it's garbage. It's absolute garbage. So I'm still hoping that it's something that I'm overlooking. It's something that I'm not quite doing right. It's I guess I'm gonna have to start. Uh, yeah, I'm gonna have to look at some of the numbers and yeah, I don't know. I don't know. It's uh, just uh, it, it's an ongoing, maddening process, and it's something that at least with this system, I've never really dove in too deep into. So yeah, I'm just having to. So yeah, and Tom, I've verified the ID of these um, stars, and I think a couple of them, um, for some reason, and I'm not quite sure, I'm not properly I'm identifying, but but um, for the most part, I mean, out of 50 or 60 stars in the field of view, 59 of them, 58 of them are correct. So yeah, it's just absolutely maddening, and really, really, it's not too complicated. I mean, I've done this before with other systems, and just have never had this kind of trouble before. So it's absolutely maddening because I'm not quite sure where the inconsistency is coming from. And as I said, I mean, if it was a case where I was trying to measure the actual magnitudes of these stars, then I would have to take into account all kinds of other stuff, like extinction. The focus would probably be more of a problem. Um, uh, you know, um, yeah, but because I'm looking at the differences, and this is broadband. I'm comparing apples to apples, and I'm just uh, yeah, it's absolutely maddening. So, but as you can see, I've got a smile on my face because I mean it's fun. It's fun. It's just absolutely insane. It's just absolutely insane because you know when I mean some of the differences are very, very promising, right? I mean, I'm seeing 30, 40 millimagnitude differences, which is absolutely fantastic, right? Now, I mean, it's not as good as I would absolutely want, but as I said, if I can get anything better than about a tenth of a magnitude, then I am gold. I am totally gold, because that opens up the possibilities of lots and lots of things. Um, but ah, the problem is that sometimes I'm seeing that, and sometimes as I said, I'm seeing you know differences of just huge, huge, huge amounts, and there's just no consistency at all. Yeah, um, uh, noise, um, artifacts, all of that is sort of the noise is sort of averaged out, um, because I'm taking 20 images, so there is noise, there is noise, and that's something that I need to look at, but the noise is very, 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 very low relative to the signals. In fact, I'm seeing a signal to noise ratio. Now, that of course it depends on the brightness of the star, but for like the brightest stars in my field of view, I'm seeing a signal to noise ratio of like 2000. So that's plenty. It's plenty. Um, Artifacts are taken out in terms of calibration. So yeah, I'm not seeing um, 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 the artifacts. The one thing that I'm not removing is bad pixels, um, but there aren't a lot of those, and mm, they're they're not. I mean, I mean, star to star, I'm seeing these huge inconsistencies, and um, you know, bad pixels. There might be a few on the entire CCD. So, yeah, that's not it at all. I'm I mean, the direction that I have to go is that there's something that I'm just not doing right, and so that's sort of where that is. It's just absolutely maddening. Cheers. Maddening, maddening. Being a mad scientist though is something that I am used to, that I enjoy. I've been doing it my entire life, and you work through these kinds of problems, and yeah, I thoroughly enjoy the whole thing. It's sort of like um, um, observing at telescopes, right? Um, if you're into star hopping, right, uh, you just have to learn how that's done. And you struggle and you struggle and you struggle and you struggle and you figure it out. So, yeah, I'm just in the process of that. And I've decided, to share this process with you, my friends. So, yeah, it's interesting. It's interesting for sure. So yeah, yeah, no problem, man. Yeah. Uh, I'll figure it out. I'll figure it out, and I will let you know for sure, because it's just yeah, it's uh, but yeah, you know, the process can just be absolutely maddening. So, but yeah, I'll figure it out. No problem at all. Now, the good news is that archive.org is back online. I just noticed they have their Wednesday, the 28th of March listing up. So that's up and running. Random.org is back up and running. So what I sort of thought that I would do tonight is let's do another object of the day, huh? Cheers. Oh, yeah, crazy, absolutely, absolutely insane. So I'm going to share my screen here. Doink. And we'll go over to random.org. And what do you say? Let's do an NGC object. So NGC stands for New General Catalog. This is a catalog of non-stellar objects. So that'll be galaxies, planetary nebulae, gaseous nebulae, open clusters, and globular clusters. And there are 7,840 of them in the NGC catalog. We're going to have random.org here choose our uh, um, NGC object. The info whores. That's an interesting name. Glad you could stop in. We're talking astronomy here. We're just going to be looking at an NGC object very, very soon. Could be anything. Don't know. There's 7,840 of them. And random.org is going to choose a number between 1 and 7840, and that'll be our object of the day. And then we're just going to do a little bit of a dive into that to learn a little bit about it. So let's do the drum roll. Boink. All right, NGC 2707. So let's go to Simbad. It's my favorite astronomical database. And we will do a search for NGC 2707. Right? That's what I said. 2707. Yeah. NGC 2707. Probably a let's go back. Maybe I need to not put a space in here. Uh-oh. Uh-oh. NGC 2707. Not in the Simbad database? Oh, give me a break. Give me a break. Is it going to be one of those days? Let's try. Yeah, it's going to be one of those days, isn't it? Let's try that. Wow. It's not going to be there, huh? Let's see if Ned has it. This is the NASA extragalactic database by name. NGC 2707. That'll be absolutely insane if there's nothing about that. There we go. Okay. Gee whiz. What is it? Let's see. This It's not giving an object type. And so here's the equatorial coordinates, 8 hours, 56 minutes, 5.7 seconds, negative 3 degrees, 3 minutes, 59 seconds. Object type, I don't know what that means. Is that an asterisk or a star? I don't know. Hmm. Wow, there's not much to this little guy. Say that much for it. See if I'm gonna go Simbad this way and see if it finds anything. No. Wow. Well, isn't that interesting? Let's see if this does anything. 27. Oh, this is saying 2705. No, that's not it. Holy moly, we found a hot one tonight. No NGC 2707. Huh. Let's let's do the ultimate search here. Well, of course, this is in a different language. Let's translate this. Wow, it's a star. Well, that's extremely interesting. I had absolutely no idea. So I would say, I would say that NGC 2707 is a misidentified NGC object. Huh, huh. Well, let's try this. Let's go to archive.org and see if there's anything that's I've never seen that before. And gee, I thought I'd seen everything. Oh, yeah, nothing there. Let's do 2707. Uh, maybe in search through the abstracts. Oh yeah, that's going to be too painful. Let's try 2707 in the title. It's been one of those days, guys. It's been one of those days. That's amazing. That is really, really interesting. I wonder, let's see, some of these galaxies are really nearby, like 0.05 arc minutes away. So let's um let's go to Simbad, right? And I I just want to get a chart. I want to get a picture, and I would pull up Stellarium, but that would bring this poor laptop down to its knees. Now look at this. This is kind of interesting. They're actually saying that. Oh, okay. that 2702, 2705, and 2700 are also just stars. Wow. So these, I guess I didn't know this, that 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 some NGC objects are misidentified uh, stars, because the NGC catalog is supposed to be just non-stellar objects. So these are uh, apparently stars that somebody thought was a galaxy or something, and turns out that it's just a star. Hmm, fascinating. Let's see. Now, NGC 2699 looks like it's an elliptical galaxy. So let's go over there, 2699, and we'll go to Simbad. Okay, Simbad. I just want to look at sort of the field of view, the area, 2699, 2699, and pull up the picture here. This is the digital sky survey, and we can zoom out here and just sort of see what we're dealing with here. There are galaxies around, for sure. Lots of galaxies here and there. But what I want to do is I want to get onto these coordinates, 856 5.6. So 856 5.6. And here you can see the RA index up here. So 856 5.6. So somewhere 5 point, okay. So let's remember these two stars, okay? And then we're going to go negative 3, 357. Negative 3, 357. 3, 3. 3, 357. So, yeah, wow, there's just, I mean, that that guy right there, 856.6 and negative 3. So that star, this guy right here in the crosshairs, right next to the crosshairs here. Whoop, let's move him over. Come on. Are you being stubborn? Here we go. So this guy right here was misidentified as NGC 2707. Fascinating. This guy right here. That's pretty interesting. You can see that there are some galaxies in the area. Probably looks like, because they're all sort of the same brightness, more or less the same size, you can sort of assume, make a broad assumption that they're all about the same distance away, which probably means they're all, sort of associated with one another. But yeah, it sort of is looking like 2707 is a misidentified star. And yeah, pretty interesting. I wonder, let's see, can we look at this with another survey? 2MASS, can we do this? I don't know. Okay, 2MASS. identified it too. Not quite sure how that works. Gaia identified it. Gaia identified. Well, I didn't identify that. Wow, that's pretty interesting. Pretty interesting. That well, which one is it now? This one. So that is a misidentified galaxy, I guess you'd call it. Pretty interesting. Didn't know that that kind of thing would happen. And it looks like there's a few, right? It looks like there's a few that are stars. It also looks like there's, well, it looks like there's a double star here. Pretty interesting. Um, so yeah, these are probably all sort of associated with one another, meaning that they're probably gravitationally bound. You know, they're part of a cluster. So let's zoom out a little bit and see if there's anything interesting in the immediate area. But yeah, here's that little dot right there is NGC 2707. That's pretty amazing. Pretty amazing. I'm going to I think I can do a snapshot of this. Can't I do a snapshot of this? Snapshot. I think I can. I think I have that technology. It's looking. Screen. Screen capture. Is that what it's called? Capture. Huh. I thought that we had a. I thought we had a screen capture here. I guess not. I can do it this way, I suppose. I can do a. Let's see, which one is it? This one? Yeah. So I can do a print screen, and then I can open up Microsoft Word, I think, and I should be able to paste it in there. Oh, it's not letting me do that. And struggles, the struggles that we have to go through. Let's see if paint, is paint going to let me do it? I'll take anything. It's been one of those desperate days. I've got a kitty on the lap. Nope, it's not letting me paste there either. Wow, pretty amazing. I'm gonna have to. I'll have to get this on a different machine and do a little screen capture of NGC 2707, which isn't a non-stellar object at all. It's a very stellar object. That's pretty cool. Just a little cluster of galaxies here. You know, you can sort of see there's a few, and 2707 is that little dot right there. Yeah, pretty amazing. Pretty amazing. All right. Well, that is our object of the day. I hope you enjoyed that one. I certainly did. Yeah, pretty amazing. So let's take a quick look over at Archive, see if there's anything interesting over there. I mean, things couldn't possibly get any worse today, could they? Oh, so I'm gonna get some hydrogen hydroxide in me. Hold on one sec. Cheers. All right. Let's see. Come on, you slow machine. Misaligned accretion and jet production. Seeing Larson's relationship in massive clumps. Oh, I don't want to see that word, stellar photometry. A new technique for mapping distances across the Perseus molecular cloud using CO observations. That's carbon monoxide um, and stellar photometry. An extensive photometric. See, everybody's doing photometry except me. Artificial guide stars for adaptive optics using unmanned aerial vehicles. Huh. Yeah, that's something that I haven't talked about yet. I was extensively involved early on with adaptive optics, um, and I need to talk about that a little bit more at some point. Um, but this is kind of interesting. Um, what what you can do, uh, sort of in a nutshell, is that adaptive optics relies on sort of a bright star to be in the field of view of your science camera, and you can measure um, that bright star in sort of a special way to see um, um, what the atmosphere is doing, and then quickly compensate for it. Well, sometimes you don't have a bright star um, next to the target, um, that you're um, um, interested uh, in um, measuring, right? So what you have to do is you have to create um, an artificial star, and you can do that with a laser beam. I'm not going to get into the details now, but yeah, Tom. Um, and usually uh, they shoot the laser beam from the telescope itself. But in this case, they're using apparently unmanned aerial vehicles in order to do it. So, yeah, that's kind of interesting. I'm going to have to look at that a little bit more. That's pretty far out there, I think. A spectroscopic survey of the small near-Earth asteroid population. Okay, that's cool. Extended distribution, polarization modeling, local ratio thermal dependencies, condition of dust evacuation from the first galaxies, astrochemical evolution. Phew. High frequency oscillations in the atmosphere above a sunspot umbra. Cool. Uh, color locus method, instability, supersonic cold streams, statistical analysis. Ooh, systematic search for rings around Kepler planet candidates. In order to do that, you have to have exquisite photometry. There's that nasty word again. Global mean, the planetary atmospheres, measurement of source star colors, neutron star mergers, not seeing really anything jumping out at me. I mean, all these things are um, you know to a certain extent pretty interesting, and they're all jumping off points into further investigation, either through the topics that they're talking about specifically, or the references that they bring up. Have we seen all glitches? No, you haven't seen mine. Interplay between gas and magnetic fields, non-kinematic solar dynamo models, three-dimensional census of the Milky Way galaxy. Astrometry from space has unique advantages over ground-based observations. The all-sky coverage, relatively stable, and temperature and gravity invariant operating environment delivers precision, accuracy, and sample volume several orders of magnitude greater than ground-based results. Even more importantly, absolute astrometry is possible. So Gaia provides 5D phase space element, 3 spatial coordinates, and 2 space motions. Plane. That's kind of interesting. We can look at that. There might be some interesting pictures in that one, if nothing else. The decisive future of inflation. White dwarf main sequence binaries. Arches cluster revisited. I don't know anything about the Arches cluster. Located within the central region of the galaxy, the Arches cluster appears to be one of the youngest, densest, and most massive stellar aggregates within the Milky Way. As such, it has the potential to be a uniquely instructive laboratory for the study of star formation in extreme environments and the physics of very massive stars. So that's kind of cool. N-body simulations, those are always fun. Neutron star mergers, lots of new papers. Wow. Sort of an unusually large number of papers. I think they missed Tuesday. I think they missed yesterday, so they're probably having to catch up today. So seeing quite a few more. Globular cluster without iron spread, but with an extreme magnesium um, aluminum anti-correlation. JWST, I'm sure you've heard, has been postponed. But you know what? Get it right. You know, make sure that it works, and then deploy. You know, launch, deploy, and enjoy. Right? Make sure that it works. Who cares? Who cares how? Really? Who cares how long it takes? How expensive it is? If there's a will to do it, cost and time really aren't major factors. And if they are, then well, we got to change our priorities around a little bit, and figure out what's important. And I think that JWST is important enough. Let's take our time. Let's do it right. We've only got one chance to make it go. So yeah, let's do it. Hey, I'm gonna let a kitty out of the office here really quick. I'll be right back. I was sort of keen on that Gaia 3D map of the galaxy. Where was that? Yeah, wow, lots of papers today. Here it is. Three-dimensional census of the Milky Way galaxy. That looks a little cool. Let's take a look at that for a couple of minutes. It looks like we're into our hour, so we'll just take a quick gander over here. It's one of the cool things about doing a daily thing is that just relax, have fun, look at some astronomical stuff, think about some astronomical stuff. Milky Way galaxy, a Rosetta Stone for astrophysics. Yes, indeed. Distances. Measuring distances is tough. Tough. Parallax only gets you, a few parsecs out. And when you're dealing with things that are, tens of thousands, hundreds of thousands of light years away, parallax doesn't work anymore. So, even from space, several um, contributions of the apparent path of a star across the sky. So, yeah, in the end, this is a star's motion as seen by Gaia. That's awesome. Great pictures, man. Great illustrations. Okay, that's kind of interesting. Here's a picture of the insides of Gaia. Kind of neat. Angular primary mirrors. I don't know much about the actual spacecraft itself. Two telescopes. There's two telescopes on Gaia. Huh. Okay. Focal plane. I know that they're doing imaging and spectroscopy. I think they're doing spectroscopy. Either that or sort of wideband photometry. I'm not gonna dive too deeply into this. We'll just sort of casually scan through. And here's a Gaia image of a relatively bright single star. This illustrates the system point spread function. So yeah, not round. Definitely not round, but it doesn't matter. As long as you know what you're dealing with, you can deal with it. So this looks like a pretty cool paper to sort of get a good idea about Gaia performance and um, yeah, just an overall view of the project itself and what's involved. Maybe I should read through this. Maybe it'll give me some ideas. Oh, they have Gaia alerts. That's kind of cool. I didn't know that. Wow, I'm gonna have to dive into this a little deeper. I always enjoy transient events. LSST, when that comes online, they're saying that there's going to be 10 million transient events a day. Main the state. Yeah, okay. Thought this was talking about Cartoon Milky Way. Okay, I don't want cartoon. Cartoons are nice, but hmm. Termination presentation true intrinsic luminosity and colors of stars. Okay, so they've got a. Okay, so this is the HR diagram from Gaia's first data set, also showing velocities. So their colors of these dots are showing transverse velocities. That's kind of cool. Some spectra. Yeah, I thought that they were doing spectra Gaia. Signature of constant frequency gravitational wave propagation from the direction of the North Galactic Pole. Huh. Okay. 2 billion, 2 billion, over 2 billion sources being observed. Quite a quite a survey for sure. There's some of the people behind Gaia. I'm just going on and on. Okay. Well, pretty interesting paper in terms of sort of a detailed overview of Gaia. I didn't really see much about the 3D census part. Hmm. I don't know. Yeah, it's been one of those days. I'm going to exit out of that. All right. I think that it is definitely time to end this particular live stream for today. Um, it's yeah, it's been a bummer day in terms of me being able to characterize this system. It's been a bummer day because the object of the day turned out to be a non-object, and looking at sort of an interesting title to a paper turned out to be sort of like, huh, ho hum. So yeah, definitely one of those days today. That's how it goes. That's how it goes sometimes when you're doing astronomy. Sometimes you get good days, sometimes you get bad days. All right, this this will be a one of those bummer days for sure. But we did think and talk astronomy for an hour anyway, and that's always fun. Brings a smile to my face, no matter what. So hope you enjoyed. If you chanced upon this, make sure to subscribe. I will be doing this again tomorrow, same time, 2 hours UTC, same place, right here, same cosmic as well. So yeah, all right. Well, hope everybody has a good evening and a good day tomorrow. I will definitely see you again in a little less than 23 hours and about 20 million kilometers somewhere. I don't know which way we're actually going. We're actually, I mean, relatively speaking, we're sort of moving in a spirally pattern anyway. So, yeah, it's dizzying to contemplate our motion as we move through space. But all right, I'm gonna get out of here for now. Take care, and I will check in with you again tomorrow. Maybe tomorrow might be slightly a better day. Who knows? Who knows? All right. Take care. And all right. Have a great one. And I'll see you on the spin.